Hey guys, today for our last lesson of the year, we're going to look at finding the distance from a point to a plane. So, first of all, let's consider a plane pi, which we will give by ax plus by plus cz plus d equals 0. So there's our plane. The normal to the plane is going to be given by, we'll call it n, and that of course is a, b, c. Whoops, there we go. Okay? So if I have a specific point on the plane, I'm going to call that point, let's see, so we'll call that P0, so that's our P0, X0, Y0, Z0. And then we're going to have a point that is not on the plane, which we're going to call P1. Okay, P1, which is X1, Y1, Z1. So the distance between that point to the plane is going to be given by the equation. And I'm going to give you two different versions here, just like I did before. I'm going to give you d equals, and we're going to have the magnitude from point P0 to point 1. We're going to have that vector, and we take the dot product with the normal, and then we divide by the magnitude of the normal. Okay? Alternatively, and perhaps more usefully, we will have d equals, and we'll have a x1 plus b x1, or so x1. That should be a y1 plus c z1 plus d, okay, and the whole thing is over the square root of a squared plus b squared plus c squared. Okay, so that's our distance formula from a point to a plane, and you notice it is quite similar to a point to from a point to a line. But anyway, so I'm going to walk you through number A here, okay? And what we're going to have is number A. Yeah, 1A. That is what I mean. That's exactly what I meant. So what we're going to do is we're going to say, first of all, we're going to find point P0 to B, okay? So we're going to find that point, which you're just subtracting the x, y, and z coordinates, so we are just going to get 1, 3, and negative 2. Okay. Secondly, we'll find the normal vector, which of course now I'm using the that first version of the equation here. So I'm going to take the direction vector of u, and then I'm going to take the direction vector v, and I'm going to find the cross product of that. Now I've done it ahead of time. You can double check my math if you want, but what I got was 1, 4, and negative 2. Okay? So there are my two vectors. And so I am ready to use the distance formula. So I'll say d equals, and it's going to be P0b, and the dot product with n. And then we're going to divide by the n magnitude. Okay? Let's see. And so now what I'm going to do is I'm going to take the dot product. Okay? And then I'm going to divide by 1 plus 16 plus 4. And so I get 17 over root 21. And there we go. All right. So that's using the first version of the formula. We'll do this next one using the second version of the formula. No, we won't. Actually, I'm going to leave part B. Sorry, part B is the one I'm going to leave for you. It's equation 2. I'm going to do that. So part B I want you to do on your own, and we can take it up in class if you desire. And then we'll take a look at example 2 here. So we're going to find the distance between R and this point. This time the plane is given in Cartesian equation. Okay, it's our Cartesian equation is given, sorry, is what I mean. So what we're going to do is we're going to go straight into the distance formula. Okay, and I'm going to use this one right here. So we've got A x1 plus B y1 plus C z1 plus D, and the whole thing is divided by A squared plus B squared plus C squared. So what do I get? Well, I get 2 times negative 2 minus 3 times 0 plus 3 minus 6. And I divide the whole thing by square root of 2 squared plus negative 3 squared, whoops, and plus 1 squared. Okay, and we simplify that and we will get 7 over root 14. Whoops, 7 over root 14, which actually does simplify. Yeah, whatever, I'm gonna leave it like that. Okay, so that's it. There we go. So that's the distance between a point and a plane. Okay. Again, we could rationalize that. I haven't rationalized one in a while, so I'm gonna do this. So just to remind you, because at some point, sometimes whether you do this or not, it's something that it's technically what you're supposed to do, but oftentimes it's just, it doesn't happen. So anyway, we get 14 like that, okay, which gives us 7 root 14 over 14, okay, and so we're just left with root 14 over 2, and that's our final answer. Okay, there we go. All right, so the only other thing that I'm going to go over with you, I'm going to leave most of these questions for you to try on your own. The last thing that I want to look at is the distance between 2 parallel planes. So to do this, first of all, you're going to find a specific point on one of the 2 planes, okay? Find a specific point on one of the 2 planes. Okay? Because remember, because they're parallel planes, if you take any point on one of the planes, the distance from it to the other plane is going to be the same as if you took any other point. So now all that's left is we find the distance between that point and the other plane. Okay, just like we did in the previous question. Distance from that point to the other, whoops, oh man, to the other plane. Okay, and there you go. So that's it. So we'll quickly do this next one. So if I look, I'm going to find a point. I'm going to use pi. We'll use this plane here. Okay, and so a point that is on that we'll call P1. And so, and what we'll do, yeah. So it's going to give us 1, 0, 0. Find the x-intercept, and you could use any point. Okay. Usually the easiest way is to find one of the intercepts, because then you're dealing with zeros. and that is on plane 1. Okay, so now I just have to find the distance between that point and plane 2. Okay, so I'm going to say, well, then the distance is 2 times 1 plus 4 times 0 minus 6 times 0 minus 4, and the whole thing is divided by the root 4 plus 16 plus 36. Okay, and so what it equals is 2 over 56, which we can reduce to 1 over 14, or root 14, sorry. Okay, and there we go, and that's it. So, I do want you to try the questions on the back of the page by yourself. And so, this concludes our course. So, till next time, go Sabres!